This is the Cerebellum cycle. It's a self-balancing unicycle and is our senior project. So, the first component we're going to talk about is the battery pack. The battery pack is 36 volts and it runs between 10 and 30 amps depending on what the hub motor in the base of the unicycle is drawing from it. There's a positive lead which comes from the battery pack into a downstep. The downstep converts the 36 volt battery into 10 volts for the myRIO to use. The myRIO operates between 6 and 16 volts, so we chose 10 volts as just a safe middle ground so we don't overload anything in the system. There's a positive lead which comes up to a gyroscope and accelerometer. They're one IMU, they're all embedded in this chip, and what that does is it senses the orientation of the unicycle frame, and it sends a signal through the 5th and 6th pins down to the myRIO. The myRIO senses that and sends a signal into a servo amp. The servo amp actually regulates the voltage from the signal which is sensed by the myRIO to the output of the voltage which is sent to the hub motor. So the hub motor actually gets a signal from the pins connected right there, and then it is regulated by motor 1 and motor 2, positive and negative. It comes down to the hub motor and generates the corrective motion to reorient the frame of the self-balancing unicycle.
I flipped the switch. In 30 seconds, the myRIO is going to apply the LabVIEW program to balance the system.
So you can see we have these big weights on the front of it, and that's because our battery was so heavy that we had to add counterweights to the front. And we also had to add the training wheels because our IMU is only working in one plane. And so to make sure it didn't tip left or right, we added the training wheels to keep it in a forward-back motion. And here you can see it balancing.